Okay, so today I'm going to tell you guys about differential. My name is Ilham Makarim from Mechanical Engineering. My NPM is 20064888354. So differential in a function of one changing, differential f in x means the existence of derivative f x and x. This is equal to the f graphic that have line that not asymmetric in x. The differential. To understand the concept of differential a function to change, you must take a look at this graphic right here. This is an example of function x and y have x, y divided by x plus y. And you need to look at the f, is it identical with the 0? And the y section, is it equal to x except in 0 because it has a half? And there's an fx and fy. Both of these must be 0. That means that this graphic doesn't have a intersection line in the upcoming points. And what is the function of derivative? We need to do not see the difference between xy and xy with a different equation. So we write p equals to x point y equals to x point y, and fp equals to f x point y. And we need to remember that fx and x equal to limit h to 0, f x plus h minus fx divided by h. That's the number one, and if it analogies will be like this one, fx and p equals to limit h to 0, fp plus h minus fp divided by h. But divided by h factor is nonsense. So there will be a new formula. It's called fx and x equals to limit h to 0, fx plus h minus fx divided by h. And then from this formula number 1, we can word it in another sentence like this: fx plus h minus fx equals to fx and x h plus h. Because with this h is 0, and we can see on this number 2, what is the definition of fx and p? We can see on the next slide. We will say that f can be differentiated in p if a q vector just the same as the p. So there will be a new formula: fp plus h minus fp equals to q h plus h delta h. With delta h means to 0, that means h is 0. If we have a q vector is a unique one. Vector q is called f gradient in p, which symbolized as delta fp. And this is another formula, because there's some things we need to look from definition above. Number 1 is fx and x derivative is a number, but a gradient of delta f is a vector. And the second one is this, that the delta fp h shows that the final result of the equation from the two vector. And number 3 is definition have an definition of across dimension. And we have the next measure is gradient gradient equation. Theorem A is if f had two function that differentiate in p equals to xy, then derivative partial first from f is in p, and this is the formula. As you can see, with the same method, if function g have three changes and differentiate in p, xyz, and then we can see this formula. And this is how to calculate the gradient. To use the theorem A, we need to know that f and g could be differentiated. But how can we know it? So there will be a theorem B. If f had a derivative first partial in society from p, and if partial derivative p is continued in p, then it could be differentiated in p. And this is the example of the equation of the gradient. And this is the second example. This is the third equation. As you can see, x, y, z. This is x in z plus x, y, such the delta f, 1, 2, and 0. And this is the solution. So the final results is 4e plus j plus k. And there's also the rules of the gradient. There's three rules. Gradient has the same rules as the derivative. We need to remember that d looked as like some operator is a linear, and so does operator delta, that we should call it operator del. And the last one is theorem C is a linear operator, which is a two point in it. It's a delta fp plus gp equals to delta fp plus delta gp. And the second one is delta alpha fp equals to alpha delta fp. So we have a final result, and this is the result, is delta fp gp equals to fp delta gp plus gp delta fp. I think that's it from me. So thank you. Sorry for my bad English, because I'm sorry if my voice don't sound well because I'm in outdoor. Thank you.
Greetings everybody, my name is Fachri Ramanda Buzaar. My NPM is 2006489275. I'm from Civil Engineering. Thank you. Assalamualaikum everybody. Now I'm going to continue about from my friend's presentation. It's me next. Okay, so let's go to the topic. Okay, so it's differential. We have this equation. So our point is to make it fast. So how we need to write it without p, so it's more simpler. So we change it. So we have this equation afg per ax I plus afg per ay j. So through the equations, we have the answer is fg plus gf. Okay, so we have continuity differentiality. So in this theorem, f is defined at p, then f is continued in p. So we have this equation over here. So fp plus h minus fp less than fp h plus h sigma h. So it's defined on this equation. So we have f times p plus h minus fp less than fp times h plus h sigma h. So the equation is, we make it simpler. So it's fp h cos theta plus h sigma h. So we have direct derivative and gradient over here. So I have some couple info. So what we need to know. So we need to remember the f x y. So and then we need to remember about derivative fx and fy. It can be determined changes and the slope of the line at x and y. So what we learn in this derivative and gradient is the changes f at directed line. So also the derivative is related to the gradient, like the topic, it's derivative and gradient. So what we use on this next topic, we use factor units, so it's more easier. Okay, so we have over here is the vector units at positive. So it can be written like this. So fx and fy lim h through 0, both of it. So it's the same equation, but it have the different vector units. The x use I and the y use j. So the correlation is, remember, the fp is given by these equations. So like the A term said, if f has the partial derivative continue at p, then f have directed derivative at p at vector units. So the equation is this equations. It's duf xy equals ui fx xy plus u2 fy and xy. So we have example over here. So this is the equations. Is divided net derivative f at 2 and minus 1 at factor a equals 4i plus 3j. Okay, so we need to substitute it to like this. As you can see, the equation is 8 at x min y. So we have this, and minus x plus 6y, we have this. Okay, that's all from me. Thank you for watching. My friend will continue next. Thank you.
Hello, my name is Ferro. I'm from civil engineering. Hello, my name is Ferro. I'm from civil engineering.
Okay, now I'm going to explain about tangent plane to level surface. Okay, we have one example here. Find the equation of the tangent plane and normal line at the point -2, 1, and -3 to be ellipsoid. And the equation is here. We see it. The ellipsoid in the level surface with k equals to 3 of the function. Okay, we have the function here. And next, therefore, we have x, x, y, z equals to x per 2, fx minus 2, 1, and minus 3 equals to 1, minus 1, and fy, xy, and z equals to 2y, fy minus 2, 1, and minus 3 equals to 2, and so on. Then equation 19 gives the equation of the tangent plane at -2, 1, and -3 as -1 multiplied by x plus 2 plus 2 multiplied by 1 and -1 minus 2 per 3 multiplied by z plus 3 equals to 0, which can be simplified to this equation. And by equations 20, symmetric equation of the normal line are, okay, this is the equation, okay. Okay, I'm going to explain about how to find maximum directional derivative. Okay, we have one example here. Find the direction for which the directional derivative of fxy equal to 3x power of 2 minus 4xy plus 2y power of 2 at -2 and 3 is a maximum. What is the maximum value? Okay, so the solution is the maximum value of the directional derivative occurs when f and the unit vector point in the same direction. Therefore, we start by calculating f, x, y, x and y. Like we can see 6x minus 4y and fy, x and y equal to -4x plus 4y. So we start by calculating it like this, and then we evaluate the gradient at -2 and 3 that is given from the question. And after evaluating, we need to find a unit vector that points in the same direction as -2 and 3. So the next step is to divide -2 and 3 by its magnitude. Okay, which is like this. And after that, to find the angle corresponding this unit vector, we solve the equation by using cos theta -6 root 61 per 61 and sin theta 5 per 69 root 61. Okay.
Selamat pagi semuanya, nama saya Danendra Kurniawan, NPM 20066064886. Saya dari kelompok 6. Di sini saya akan menjelaskan mata pelajaran kalkulus tentang derivatif berarah dan gradien sampai ke aturan rantai yang pertama. Okay, we want to explain you about derivative and then the gradient. And in here we have the problem that we want to solve, that t equal exy min xy square minus x square y z, and then this one is the number that we want to solve. That delta t is exy min y2 minus 2 xy z I plus xy minus 2xy minus x square minus 2 plus x square y, and then the end with the t, it means constanta, and then the delta t is, and then we want to input the 1 minus 1 and 2 is equal minus e minus 1 plus 3i plus e1g plus k, and then the minus delta t, and then we want to put the insert the number, and then e minus 1 mean 3i minus e minus 1g minus the constanta, and then the e equal fxt, and the fx is definition by dy per dt equal dy per dx, and then dx per dt. So the z, f, x, y, and the x and y is the function of z, f, x, and y. X, t, y, t, and then the z equal f, x, t, y, t. dz per dt is alpha z per alpha x dx per dt plus alpha z plus alpha y and dy per dt. So p equal x min y, delta p equal delta x min delta y, and then delta z equal f p plus delta p minus fp. And then the next page we have what is f. F is definition by delta z, f p plus delta p minus f p minus delta f p, delta p plus delta p, the total of delta p. Well, fx p delta x plus fy p x delta y plus delta p, the total of delta p. Dengan so the total delta p is 0 and ap is 0. Delta z per delta p equal fx p delta x per delta t plus fy p delta y per delta t ap at total ap. And then we want to solve the problem. Delta z sama dengan equal fx d delta x per delta t plus fy dp delta y delta t plus delta p delta t, the total of delta p. So we want to solve the problem with the root. Delta p per delta t equal root delta x square plus delta y square per delta t, and then equal root delta square plus delta y square, and then we get this definition, and then this one is the same of question or the problem that I solved, and then this one the point is when delta t equals 0, delta x and delta y is equal to 0. X, f and y, xt and yt is continue, is definition by delta p equal 0. Thank you for the explanation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Gilang Yahya Nakshabandi and my student ID is 2006 606492 from group 6, and I'm going to explain about the derivative for function of two variables, and the subtopic is the chain rule.
Okay, so I'm going to explain the chain rule from the derivative for two or more variables. So I'm going to use to explain the first theorem of the chain rule. So it's dz over dt equals the partial derivation of z over dx times dx over dt plus the derivation of z over dy times dy over dt, right? And then I'm going to show the sample questions of the chain rule. So for example, I have w equals t squared minus t tangent s, and t equals x and s equals px. So like we looked at w equals t squared minus t tangent s, and the t is equal to the function of x, and then so as the s, and then so the question is how the w over dx when x equals 1/4. Right, so so I'm going to use diagram to make it simple. Okay, so for example, like here is w and here is x. So I'm going to reach x from w, right? But I have to take away through t or and s, right? So this is t and this is s. As the question mentioned that t equal x and s equal px, and then from w to the t we have to use the partial derivation of w over d over dt, and then from t to the x I have to use dt over dx, right? And so as the right side. So from w to the s we have to use the partial derivation of w over ds, and from s to the x we have to use ds over dx. Okay, so it's equals to this theorem, right? Okay, so according to the diagram that the questions asks, we have to use the first theorem as I have mentioned before. So this is the theorem. The dw over dx equals to the partial derivation of w over dt times dt over dx plus the partial fractions of dw, the partial fraction of w over ds times ds over dx. Okay, so Okay, so we just derive the equation, the W, and then just substitute the equations, the T and the S. So we get 2T minus tangent S. Okay, so this is the partial derivation of W times 1 as from dt over dx plus minus t second squared s times p, and then because this is in the form of t and s, so we just substitute t here as equals x and s equals px. So we get 2x minus tangent px minus px second squared px. And then the question is asked about when the x equals 1 over 4. So we just substitute 1 over 4 to this equation. So we get dw over dx when x equals 1 over 4. So we have half minus 1 minus p over 4 times 2. So right, we have minus half minus half p. Okay, so this is the final answer for the question.